All right, here we are, 10.2, the parabola. So we changed gears. We just took a big jump, didn't we? From 5.8 to 10.2. We went from chapter 5 to chapter 10. I skipped 6, 7, 8, and 9. 6, 7, and 8 will come back to, at the end of the course, it's trigonometry. You all have had trigonometry, haven't you? So it'll be a nice little review. I want to save the easiest for the end. People usually fly through the trig because you've had it before. So it'll be a quick review of trig. We'll do that in the end. I want to ease into the final with the easiest stuff. Trig. So we'll come back to that. So I'll move ahead to chapter 10. This is conic sections, which means it's sections of a cone. You take a cone and you slice it in various ways. I'll show some of that later. You can get these different shapes we're looking at. We're starting with the parabola. Well, now you know about parabolas already. You've seen y equals x squared, right? That's the most common parabola you're used to. It's just a U shape. You know about parabolas, right? Why are parabolas important? What in the real world, do you know anything in the real world that people use parabolas for? So if I take the eraser and I throw it up in the air towards Chinu, you ready? Throw it to Chinu. Sorry, bad throw, good catch. So what shape did it do through the air? Upside down U, huh? Now you might think, there's a lot of ways you could do an upside down U, but it turns out anything free flying, golf ball, baseball, anything flying through the air that doesn't have its own motor, its own rocket, right? Just flying through the air, meaning it's just been given an initial velocity and then gravity's pulling down on it. Anything flying through the air, it will make that upside down U, and specifically the arc of the U will be exactly dictated by parabola equations. It's exactly parabolic. There's other kinds of U's that aren't, but anything in free flight is exactly parabolic. So that's how the military would determine where they're going to land something with artillery. It's parabolic equations with how much initial velocity they give it and where it will land. All those physics equations. If you take physics, 2A or 4A, the mechanics, it's all parabolic equations. For anything like a golf ball that you hit or a baseball, it's all parabolic. So there's one thing. A lot of people have parabolas on their rooftop. What am I talking about? Gotta here. I'll be artistic for a minute. They have a little parabola up here. That's terrible. It looks like the moon or something. I just can't do this. I can't draw. A satellite dish. You just have to imagine with me because I can't draw anything. Satellite dish. Yeah, satellite dishes. The inside of the satellite dish, the curvature in there is exactly parabolic. That curvature. There's different kinds of curvature. We'll see in this section. You get more into that in calculus. There's different rates of bending. The bending rate inside satellite dishes is parabolic. Why? Because that's what aims everything inside a satellite dish at the receiver. In other words, have you ever noticed there's like a receiver, a little thing that's held with some arms somewhere inside the dish? What that does, the bending on the satellite dish, which is parabola, is such that as the satellite beams things down, the curvature aims everything at what's called the focus point. That's why it's called focuses. So the beam, every where it hits, it's bent to aim at that focal point. So parabolas have a focal point. That's where they put the receiver when engineers make a satellite dish. And the bending is just bent perfectly to aim everything at that focal point. That's how headlights and flashlights work as well. If you look at your headlights, it's vice versa. So the inside of a headlight is parabolic, curved, and the little lamp is here, and it shines the other way. It shines backwards, and then everything reflects off straight. Headlights and flashlights. So, lots of things in real life are modeled by parabolas. So, therefore, we want to learn how to handle parabola equations. So, here we go. Here's what you want to put on your 3x by 5. This is probably the most important thing on the next exam for sure, maybe in the whole course. That might be too dramatic. But for sure, on the next exam, here's the most important thing to put on your 3 by 5 card. The 4 ways the parabola can go. A parabola can go up. Parabola can go down. Parabola can go to the right. Parabola can go to the left. Now, depending on which way it's going, up, down, right, or left, you're going to have different looks to the equation. Here's the deal. A parabola has both a second power letter and a first power letter. That's what's unique about him. And the direction is dictated by the first power letter. Did that sentence make any sense? So let's look at where, so this first one, this first parabola, where's he going? He's going up. Up is what? Positive y, right? He's going upwards, positive y-axis. That means positive 4ay. And I'll explain the 4a in a while. But for now, just know that means the right side of that one is going to be positive 4ay. The other side is the other letter, and it's squared, x squared. The second one is going down, isn't it? So that's negative y. It's headed in the negative y. What does that mean? That means the right side is going to be negative 4ay, and x squared is the other side. Everybody see what I'm saying so far? See how x is to the second power and y is to the first? See how one letter is second power, one letter is first? That's the unique and special mark of a parabola. The other shapes in this chapter, 10.3, 10.4, are going to be an ellipse, which is an egg shape, and a hyperbola, which has 2 branches up, down, and right, left. So those will have both letters squared. I'm pouring a lot of words at you now. Am I doing the Charlie Brown teacher? It's 1, 1, 1, 1, 1, 1, 1, 1. Here are these words. Let me say it again. The other shapes will have both letters squared. X will be squared and y will be squared. Only the parabola has one of his letters not squared. That's the special mark of the parabola. He has a letter that's just first power. Squared is what we're used to. Everything else are all going to be squared. But the parabola, special characteristic, he's got a letter to the first power. And that letter tells you the direction it goes. Right? The first power letter, y, positive y, up. First power letter, negative y, down. Now let's look at the other two. So this third one is going to the right. So guess what that's going to be? Right is the positive x-axis, isn't it? So what's going to be over here? Positive 4ax to the first power. So what's on the other side? Y squared. See how the first power letter tells the direction? Positive x, right. Problem's going to the right. This one, negative x. Problem's going to the left. So it's going to be negative 4ax to the first power. What's going to be the other side? Y squared. There we go. So there's the 4 setups for the 4 different directions. Most important thing on this exam to put in your 3 by 5 card. Super important. You'll just know that right away which direction things go up, down, right, or left, or what the basic look of the equation is. The A, what that A is, that's where the focus point is, which I just showed you, like the receiver inside the satellite dish, or the lamp in a headlight, or flashlight. That's where the focal point of the parabola is. That's where it focuses, aims everything at. We'll deal with that a little bit later. But that's what A represents. It holds that spot. It's how engineers calculate where to put the receiver in a satellite dish, or a headlight or flashlight. All right. So there we go. Let's go back to the question now. So getting back to this question, they want us to got multiple choice, just like our exam. Let's look at the picture and find the right equation. So is this parabola going up, down, right, or left? This one's going up. Up is positive y. So what does that mean? The basic look of my equation is going to be positive 4ay, right? Because that's positive y. So the right side is positive. Remember, the first power letter tells the direction. If it's going positive y, the first power letter is positive y. What's the other side? X squared. So no way and no way. It's either C or D. So far, so good? It's either C or D. We're already down to just two options based upon it's x squared equals positive something with y. Right? Isn't that what our little map here showed? If it's going, which way is it going? Up. It's going up. X squared is positive 4ay. All right, it's going up. Now, how do you know which one's right? Is it C or is it D? How do you know?
Because isn't like when the numbers like inverse like that, or it's like reciprocal or something like that. Where it's like you have 25 and 25 over 1, but it's like negative. To make 25 positive, you have to like switch it.
You might be right. That sounds kind of complex.
I just can't explain it. I don't know.
That's okay. I'm just going to try plugging in. How about that? Right? If we plug in, it's got to make it true. I mean, there's other fancier ways too. But we could just plug in. I'm sure there are. I'm sure what you're saying is true, and there's just other fancier ways. But let's just plug in. If I put in x is 1 and y is 1/25th, it's got to make it true. The real equation. Now, but what about that a thing? Yeah, what about that a thing? Let's see what we got here. 1 squared is 4a times 1/25th. So far, so good. So now, what does this mean? Well, this means 1 equals, now 4 is 4 over 1. Can I put the 4 over 1 and the 1/25 together to be 4 over 25a? That's okay, right? Well, so what? What's all that? Well, now I can actually solve for a, can't I? How do you solve that equation for a? How do you get a alone? A said I want to be alone. What do? Yeah, multiply by the upside down. How are we doing? I feel like I start to lose you about halfway through. Are you with me? Half an hour more. It's important stuff. I don't want to lose you for your own benefit here. So A is 25/4. Good, A is 25/4. So that's A, so what? Well, that means now we can go back up to our original equation. Whoops, I just erased it. Don't do that. 25/4. And I can put that in for A, huh? A is 25/4. So that means it's x squared is 4a, y, a is 25/4. What am I doing? Am I losing you? So what it is, I plugged in the point they gave me. Right? Any point on a picture, that means you can plug it in. So I plugged it in. 1 for x, 1/25th for y. Got your solve for a, multiply by the upside down, the reciprocal. A is 25/4. Then went back to the equation again. Right? This is the equation, except I don't know what a is. Well, now I do. A is 25/4. I put a in, 25/4 in right there. Now, can you clean that up? There's 4 over 1. Cancel these guys. X squared is 25y. There it is. It's C. Yeah. Yeah, I was trying to solve for A here. Let me go back and do the instant replay there. Yeah, so what I did, does everybody see what I did there? I plugged in, this is x is 1, y is 1/25th. So I plugged in x is 1, y is 1/25th. That gave me 1 squared is 1. 4 times 1, 1 times 25 is 4/25ths A. Like that. And then I wanted to get A alone. How do you get A alone? You multiply by the upside down, the reciprocal. 25/4, because that cancels out the 25s and the 4s, and A is alone. A is 25/4. And then I plugged that in, A's spot. Once I found A, I put A back into his spot. Does that make sense there? And I found the equation. Questions? All right, we better move. I can't graph these. I could give it to you in the graphing calculator. You tell me why, you may know, why could the graphing calculator not graph these? Well, it could. You have to do something really tricky. Why? It fails the vertical line test. It's not a function. Vertical line hits 2 points. So what does that mean? Well, if you tried to get y alone, right, because you got to type in y1 for your graphing calculator, you got to type into y1, right? You'd have to solve for y. But the fact is, it's y squared. So you have to square root it. When you square root it, you have plus or minus. So you could do it if you put it y1 the plus and y2 the minus. Then you could do it, actually. You'd have to be real tricky like that. Anyway, this will be on the non-graphing calculator part of the test. So let's figure out. All right. So first off, which way is it going? Up, down, right, or left? Left, which is negative x. That's the negative x-axis, isn't it? Right? This is the x-axis. This is the positive side of the x-axis. This is the negative side of the x-axis. You with me? It's headed in the negative x-axis direction. So that means it's equal to negative 4ax. Right? First power letter tells the direction. You with me? Look back here. See left? Y squared is minus 4ax. That's why you want to have this in your 3x5 card. Your first step is, oh, it's going left. Look at your card. Oh, y squared is negative 4ax. That's my basic setup. Come back here and go, okay, y squared is negative 4ax. That's basically what it looks like. Good so far? Now, what about the fact, all the ones I gave you back here, right here, these are all centered at the origin, notice. All of these are centered at the origin, whereas this one is been moved to -1, -5. He's got an x value -1 and a y value -5. He's not centered at the origin anymore. So what do we do about that in our equation? How do we make the equation reflect? This would only be for one sitting at the origin. So we've got to alter our equation so it truly represents the picture. The picture is not sitting at the origin. So what do? You do the opposite. What's next to y, -5? You go y plus 5. What's next to x, -1? You go x plus 1. Opposite, opposite. Everybody see that? What we're doing. From the picture, from the graph to the equation, what's next to x and y is the opposite of the center. That'll be the case for the whole chapter. 10.2, 10.3, 10.4, all these. It's always going to be whatever center we see on the picture is going to be the opposite of x and y in the equation. You remember that? We've done that kind of thing before, right? With opposites. Were they always opposites, though? Before? Was there anything that was the same instead of opposite? Why used to be the same? Yeah. Right. Yeah, you guys with me on that? Do you remember that? Remember when I gave you an equation? Remember when we learned to graph and move graphs around and stuff? And I gave you something like y equals x minus 2 squared plus 3. Right? We'd say, oh, okay, that's a U shape, x squared. And then what is the minus 2 going to do? It's x is always opposite, so it would actually go right to, remember x is always opposite. And what would the 3 do? Up 3. So y doesn't do opposite. Y does same is what you would normally think, right? X does opposite, y does same. Isn't that what we learned? That is correct. That would go right to up 3, be right here, and be a U shape, wouldn't it? Right? So wait a minute. We learned back then that x is opposite, but y is same. And now I'm over here telling you, nope, they're both opposite. What's the story? Am I just changing my mind? What's the story? Exactly. Just see the deal. The deal is because you're putting y and the numbers for y and x right next to them, it's always opposite. There really was no magical difference back then between x and y. The difference was we were taking the y number and not putting it next to y. If you moved that over next to y, it'd be y minus 3, which is actually up 3, so it is opposite. So that's the real story. I want to fit it all together for you, so you have it all together for the final as you move on into calculus to get that deal. So there really is no magical difference between x and y. Basically, if you put a number right next to x or y, either one, it's always going to be opposite. It's always opposite when it's right next to x or y. Right? Because the way we did the equations, the x numbers, like the minus 2, was right next to x. So yeah, that's opposite. But the y was on the other side of the equal sign from y. That's just the look we gave them. So that's why I was telling you at that time, I just said for them, to make things simple, I just said, hey, x is opposite, y is the same. Well, that was only because the numbers for y were on the opposite side. If you move that over next to y, that'd be a -3, huh? Then it would also be opposite because it's still up 3. Got it? That makes sense? So if the numbers are right next to x and y, they're always opposite. They're always opposite. And that's all we're going to do in this chapter. So they're always opposite. So there we go. There's the equation. What's A? I don't know. I don't care. We can answer the question. Let's go down the list. Could it be A? Could it be A? What's wrong with A? Yeah, it's positive here. No way. It's supposed to be negative, right? It's down. Or left, left. So it's not A. Could it be B? No, it doesn't even have y squared. It's got the x, so not C. Right? It's supposed to be y squared on the left side. Could it be D? No, it's +5. It's not -5. Can't be E, that's x. Can't be F, that's x. Can it be G? No, it's minus. Well, I guess it's H then. Yeah, it is H, isn't it? Now, why aren't they showing A? Turns out A is 1. Why? I don't know why. Probably the point. I don't got time. I'm going to move on. We'll calculate those in a minute. The answer is clearly H. Good? All right, give it a go. I'll let you do it this time. You got enough information now. I'm sure you can crank this one. So up, down, right, or left. Go, look at what those 4 different pictures for get the basic equation. So up, down, right, or left. What's this one? It's going up, positive y. Positive y. It's going up, positive y. So that means it's positive 4ay, x squared over here. Good. You look back at the map. Going up, c going up, x squared is positive 4ay. Going up. All right, so there we go. Now the center is 3, 5. What do we do with center numbers? Opposite, opposite. So this will be x minus 3 squared, positive 4ay minus 5. Good to there. Now, where do we go from here? Well, let's get the answer. Everybody see it? Could it be A? No. What's wrong with A? Yeah, it's H. Can I just jump to H, move to the next problem? It's always H, isn't it? There it is. Bottom of the list. Good? Onward and upward. Yeah. Yeah, it looks like A must be 1 again because the answer is there. Now, why? I don't know why. We don't need to know for now. H is the only possibility because that's the only one that fits the other information. Yeah, so A must be 1. That's why it's not showing. All right, number 4. So, all right, which way is this thing going? See if you can figure this out. Right, left, up, or down? Write the basic equation. So going to the right, that's positive x, so it's positive 4ax on the right side. Y squared is positive 4x, right? One's going to the right. Look back to our thing, to the right. Here, y squared is positive 4ax. So y squared is positive 4ax. Now, what's the center of this one? Right here at the origin. So we don't need to put any numbers added or subtracted next to x and y. It stays just as it is. Good? Centered at the origin. It's anchored at the origin. So when they move them off the origin, when the boat floats away from the dock, that's when we have numbers added and subtracted next to x and y. Opposite, opposite. But this one's anchored at the dock. Okay. So could it be A? Is A possible? Yeah, maybe. Could it be B? No way, x squared. Could it be C? Possible. Could it be D? All right, so it's A or C. How do we know which one? We can flip a coin. There's only 2 options now. What are we going to do? What are we going to do with that 25-1? Plug it in. That's x, that's y. So plug in. Now careful, y is 1, x is 25. Well, in fact, you know what you could do is you could just take the answer here. They're saying this is the answer. Let's just plug it in. Let's put in y1 x 25 and see if it works. How about that? 1 squared is 1/25 times 25. Is that true? Yeah, 1 equals 1. Huh? These cancel. It's A. The other one, it must not have worked. You can see. If you put in, what is it, 1 for y and 25 for x, that's not even close to true. 1 equals 25 times 25. All right. So it's A. Good? All is well? All right. Okay, so find the equation of the problem. They're giving me a focus and a vertex. All right, you ready? So here we're really gonna work on these. So what you need to do, this is a hard section, it takes practice. You really want to draw them. I know there's no graph required, they're not showing any picture on this one, but the graph, the old saying, a picture is worth 1,000 words, a picture is worth 1,000 points in this chapter. It's really helpful to have a picture. It'll really help you out. So I'm just going to draw them as we go. It'll be way easier for you. Okay, focus point. Now that focus point is in the center of the shape, right? It's like where they put the receiver on a satellite dish. Vertex, what's vertex mean? That means center. Vertex in this chapter, for any of the shapes, vertex is a fancy way. Well, no, that's not always the case. No, that's what's hard. This is a hard chapter. For a parabola, vertex means center. For a parabola, vertex means center. So the vertex is 0, 0. So this thing is centered at 0, 0. The focus is minus 3, 0. Let's put that on our graph. The first number's sideways, right? So back 3. That's the focus. Back 3, up 0. So that means the parabola is going like that. That means this parabola is going to the left. How do I know? Because the focus is always inside the satellite dish. Does that make sense? The center's at 0, 0. The focus is here. So it must be going left. Because the focus is always inside the satellite dish. That's where you put the receiver on a satellite dish. Okay, so it's going to the left. What do we do now? Write the basic equation. Now that we know it's left, write the basic equation. So left is negative x direction, isn't it? That's the negative x-axis. So it's negative 4x. It's y squared is negative 4ax. Right? Left. See, here we are left. Y squared is negative 4ax. Okay, so we got that. The center is 0, 0. It's anchored at the dock. So I don't need to add or subtract anything next to x or y. Only thing I need to find now is what A is. How do you find what A is? It's how far. Now it's time to really think about A. It's easy. It's how far to the focus. It's how far from here to there. From the center to the focus, which is clearly 3, isn't it? Yeah, there's 2 ways you can think about that. The way, so this is negative 12x. I just think, in the end, the answer's got to be negative because it's going to the left. I think that's easier than kind of worried about should A be positive, negative, whatever. You're right. I just always put A as positive. I do like what you're saying. I just always say, hey, A is just a positive number. Some people like to think, well, no, A is negative, is left. Whatever. Think it however you want. In the end, this thing's got to come out overall negative because it's going left. However you get there. There's different ways you can get there. But I just keep in mind left, negative. It's got to be negative. So y squared is negative 12x. That's how we got that. Does that make sense on that? Now, they're going to ask me for something more particular. They're going to say, find the 2 points that define the lattice rectum. That sounds like a medical term, doesn't it? Got to check your lattice rectum today. Right? So what are the lattice rectum points? Well, those are the 2 points lined up with the focal point on the curve. It's this dot and this dot. Those are called the lattice rectum. I don't know what that means in Latin. Anybody speak Latin? I don't know what that means. Anyway, I know how to find it. It's always double the focal distance. it's 2A. It's at 2A. Double, remember A is the focal distance? It's double that. So what was A? A was 3. So this will be up 6, down 6. So this is the point. Am I going too quick? So in other words, the lattice rectum are always the points at the focal depth. See, it's at, like if this is satellite dish sideways, it's at the focal depth, but it's up and down double whatever the focal number is. So the focal number was 3, double that, 6 up, 6 down. It's always double the focal. Lattice rectum, it's double the focus. It's 2A. It's double the focus, always. So that means they want the actual coordinates. So what's the coordinates of this dot right here? Back 3, up 6. What's the coordinates of this dot here? Back 3, down 6. So upper point, back 3, up 6. Lower point, back 3, down 6. Everybody seeing that? So lattice rectum points are always at the focal depth, double. They're lined up with the focus point, but they're double. What does that tell you? It tells you how wide it opens. It's giving us an indication of how wide the mouth of the parabola opens. At the focal depth, it's double how the length to the focus. That's parabolic curvature. That's how wide parabolas open, always. What's that? I know, they're bringing in Latin. It's like they're not even trying to make it nice, are they? Let's keep the Latin word here. Yeah. All right, so let's look at this one. One more. They're just going to begin the trickery. This is one of the hardest sections. This really is. It's got a lot of tricks to it. And 10.3 and 10.4 are actually a little easier. So 10.2 is the hardest because the parabola can go 4 different directions. He's more tricky. Whereas the other one's like an egg shape. That's just, it's not going anywhere. Whereas this one's hardest. It can go 4 ways. All right, so let's draw. Focus at 0, 6. So put that on over 0, up 6. 3, 4, 5, 6. Over 0, up 6. There's the focal point. Good? Directrix line. Now, what's that? I haven't told you anything about that. I'm trying to do it a little bit at a time here. Directrix line, -6. Why? Y equals. That means it's going to hit not the x-axis, but the y-axis at -6. 1, 2, 3, 4, 5, 6. There it is. So this is the directrix line down at hitting the y-axis at it's a line. That's called the directrix line. What does it do? It directs the parabola. Let me do this for you. So basically, whenever you have a parabola going up with the focal point in, right? Focal point is always inside. The directrix line is always behind the shape. And it's the same distance as the focal. So if this is A, this is also, well, it's be -A. Does that make sense there? The directrix line is the same distance as the focus point. Opposite direction. Directrix line always stands behind the shape and directs it. Maybe think about that with like a director in a movie or something that stands behind the actors and directs them. The directrix line is always behind the parabola. So if the parabola is going up, it's there. What if the parabola, for example, is going like to the right? Here would be the focus point. Focus point's always inside the satellite dish. Where would the directrix line be? Right over here. Make sense? The directrix is always behind. If the parabola is going like down, here would be the focus point, and the directrix line would be up here. You get what I'm talking about? So the directrix is always behind the parabola. The focus point is inside, and they're the same distance. The center is right in the middle of the directrix line and the focal point, in other words. It's the same distance to the directrix as to the focus. Okay, so what does that mean? My focus is up 6, my directrix is down 6, so my center must be right at 0. And which way does my parabola open? Up or down or right or left? It must go up because the focus point is always inside the satellite dish, huh? That's what they're telling me by giving me that directrix line and that focal point. They're also telling me the center must be 0, 0, because that's right in the middle of up 6 and down 6, isn't it? Y'all see all that? All right, so we got all that. So what's the equation then? We got to come up with an equation here. So which of the basic equations is that one? Yeah, it's going positive y direction. So positive 4ay, x squared is positive 4ay. You can look back. Right, going up, x squared is positive 4ay. So what's a? 6. It's the distance to the focus point. A must be 6. So it's x squared is 4 times 6 times y. X squared is 24y. So there it is. Is that good?